Evaluate the definite integral from 0 to 2 of x e to the x squared dx. We will do this using the fundamental theorem of calculus. We first find the antiderivative of x e to the x squared, and then we plug in 2 and 0 and find the difference between the two to evaluate the definite integral. But first, we would need to find an antiderivative of x e to the x squared. First, observe that we have an x squared and x, and that the derivative of x squared is 2x. The derivative of x squared is a constant multiple of x, which is present in the integrand. And so we let u be only x squared. Du equals 2x dx. And we see that we have a factor x dx in the integrand, where x dx is du over 2. So we can substitute x dx with 1/2 du. This integral is now the integral of this x dx is now 1/2 du. E to the x squared is left after we perform the substitution for x dx, but x squared is u, so we have e to the u. This is 1/2. The antiderivative of e to the u is still e to the u, and then we do a plus c. This is 1/2 e to the u, but u is x squared. To evaluate this definite integral, we don't need a plus c. F of 2 is therefore 1/2 of e2 squared, which is 1/2 e to the 4th, and f of 0 is 1/2 of e to the 0 squared, which is 1/2 times 1, which is 1/2. And so we see that the answer is 1/2 e to the 4th minus 1/2, or simply 1/2 e to the 4th minus 1. Now, alternatively, we don't have to obtain the antiderivative in terms of x. We can just simply use the substitution for the new variable. If we were to let u be x squared, then for the lower limit of integration when x equals to 0, u is 0 squared, which is 0. And for the upper limit of integration when x is 2, u of 2 is now 2 squared, which is 4. And so we can just simply rewrite the given integral as 0 to 4. X dx is 1/2 du, and e to the x squared is now e to the u. And so this is 1/2 e to the u, because the antiderivative of e to the u is e to the u, and then we plug in 0 and 4, because this integral is now in terms of u, including the lower and the upper limits of integration. These are now u, not x. Evaluate this. We have 1/2 e to the 4th minus 1/2 e to the 0, which is the same as 1/2 e to the 4th minus 1, where we obtain the same answer as before.